What's the main operator? Does everybody understand that? So you can't do a simplification because the main operator is not a conjunction. Okay? All right. So that's one thing that's going to be very different, and it's going to be a very powerful difference. Okay? So this was exportation, and this was our comment about. Okay. Now, the very last rule here is something that we will rarely ever use unless I'm intending to make you use it, and that's the rule tautology. Okay? And so if you have a box, then you are allowed to replace that with box and box. Okay? That's not saying that you're saying you now have two. It's just if this is true, if box is true, well then box and box is true as well. That follows, right? And we kind of don't need this rule in one direction. We can do this with tautology, but we could go from here back to there by tautology, or we could do it by simplification, right? So either way could get us back there, okay? And this is also a case of tautology. Suppose I have box, that could be replaced by box or box. Okay. All right. Now, I said that this probably won't be used at all in any of the problems unless I'm trying to force you to use it. Why am I introducing you to this rule? Well, because other systems, you know that we have simple dilemma and we have constructive dilemma, right? This is where we have like two consequences that are the same, and this is where they're different, right? Okay. Many texts, because remember, logicians are nerds, so they're trying to they're trying to provide a system that will let you do all the deductions with as few rules as possible. And because these were also people that were in on the ground floor of computer science, memory and CPU access were expensive, okay? So they only have the rule constructive dilemma. So where we could use simple dilemma, they only have access to constructive dilemma, and if you use constructive dilemma on the cases where we would use simple dilemma, you would get something like P or P, okay? But we want to get to P, right? And we know if it's P or P, it's P by tautology, okay? So the systems that only have constructive dilemma must have tautology to get from this to that. Does everybody understand that? But since we have both simple and constructive dilemma, tautology isn't as necessary for us, right? Okay, so those are all of the rules of replacement. They are equivalences. So anywhere you find an equivalent structure, you may change it into its equivalence. And that means a whole line or part of a line, okay? And so what I want to start doing now is I want to start doing some of the problems from 5.4 to show you how to use these, okay? And a couple things. People generally think that problems from 5.2 are easier than the problems from 5.4, because 5.4 uses all the first set of rules and requires you to use the second set of rules. Does everybody understand that, okay? So in that sense, they are harder, okay? So on the actual test, you'll have 5 proofs to complete, and I will make sure that a certain number of the problems can be completed just using the rules of inference, the ones that you've been using, okay? And then the rest will probably require you to use a little bit of both sets, okay? That being said, 5.2, the homework 5.2, you're only allowed to use the rules of inference there because I hadn't introduced the rules of replacement. On the test, you may use both sets of rules on any and every problem. Does everybody understand that? So you get the full arsenal right off the bat, okay? All right, so I'm gonna start in on some even problems. I'll do even odd. I'll do a bunch for us and then we'll go. And so your job over the weekend is to continue working on the even problems in 5.2 and 5.4, right? And the ones that you can't do, you make sure you come in and ask me, what the hell, I got stuck here, right? And if you have a solution that you're not sure of, then you can ask me about that and I'll tell you, right? Also this, when I do a solution, especially in 5.4, yours might be different. That does not mean that it's wrong. Does everybody understand that? We have lots of options now about how to do these problems, okay? So yours being different doesn't mean not right. Okay. So problem number 1 on 5.4, we have to prove B, and what do we have to work with? A, then B, and we have not A or C. Okay. So I'm going to follow my previous kind of algorithm. Look for a B, I don't know, there it is. It's in a conditional, if A then B, so to get a B I need a what? A. Now I look around for an A by itself, I don't see it, but there is this blob that has an A in it, okay? Notice it is a negated disjunction, okay? Here's a general rule for you. Whenever you see a negated disjunction or a negated conjunction, think De Morgan's, because half the time applying De Morgan's to it will be the key to the problem, okay? So let's apply De Morgan's. That means we're going to push the negation through. And let's remember what happens. When I push it through, this changes its sign, so not A becomes A. Ors become ands, and this changes its sign as well, not C. That came from 2 by De Morgan's. Well, now it's easy. I needed an A. There's an A, and it's an and. So that means I can just say A from 3 by simplification. Now I can do my regular old modus ponens and get B 1, 4 modus ponens. Okay. 3. Prove not C. I have not A and B, then not C, and 2 is not A, or not B. Okay. So, and I'm going to do this problem in 2 different ways to illustrate the point that I was making before. Not C, there's a not C, I need one of these. I don't have one of those, right? But just think about this in isolation. That's a negated conjunction. Let's do De Morgan's on it. And so I'm doing De Morgan's just on this part of that complete conditional, which means I do that, but then everything else has to stay the same, okay? So I'm doing De Morgan's on this. Let's see what happens. Push the negation through, so A becomes not A, and becomes or, and B becomes not B. All this was up here. And then everything else stays the same, then not C, okay? Oh, well gosh darn it, says if not A or not B, then not C, and look what I have on line 2, okay? Oh, so this came from 1 by De Morgan's, and we applied it to just that part Okay, but now look 2 and 3, I can do my traditional modus ponens and got not C, 2, 3 modus ponens, and I'm done. Okay. So, let me write the problem again. We have to get not C, we have not A and B, then not C, we have not A, or not B. Okay. All right. So, in the first way of doing this, I applied De Morgan's to this antecedent, right? Okay. This time, I'm going to apply De Morgan's to this. Okay. Now, look, on the sheet, De Morgan starts with like a negated conjunction and a negated disjunction, and then it goes to a conjunction or a disjunction, okay? But remember, you can go from the left formulation to the right, or vice versa, okay? So if you have the substitution instance of the right, you can go to the left, okay? And when I'm doing that, when I'm going from the right-hand one back to the left-hand one, I will say in reverse. So like, if I say De Morgan's, that means, hey, look at the left side, I'm going to the right. If I say De Morgan's in reverse, that means look at the right, I'm going to the left. So there's no such thing as De Morgan's to the reverse De Morgan's or something like that. I'm just adding that in so that you can follow along easier, so you can say, oh, I'm starting here and I'm going there. So you know which, okay? So, I'm going to do De Morgan's in reverse, right? So I'm starting on the right-hand side. So I'm going to pull out a negation, as it were. So I pull it out, that changes the not A to an A, that changes the or to an and the not B to a B. So that's from to by De Morgan's. We don't say De Morgan's in reverse, we just say, okay. And now look, 1, 3, not C, 1, 3, modus ponens. Same problem, 2 different solutions. Both of them are perfectly good. Everybody got that? So do not panic if your solution doesn't look like mine. Probably right.